Hello friends. Every data structure you will learn, whether it's stack, queues or trees, is built on one simple foundation, that is the array. Arrays are everywhere, from storing students' marks to managing data in databases and apps. So today let's master the basics of array, and in this video we will learn how they are stored and a very important concept, why indexing starts from 0, and few other topics. So let's begin. What is an array? An array is a collection of elements of similar or same data types, and the elements in an array are stored in a continuous memory location. Let me draw you an array. Please forgive me for this bad drawing, but this is, you can think of it as an array, and each box here store a value. Okay, so each box here store an element, and each element has a unique address which is known as index, and index in array starts with 0. So this 2 is stored at an index 0, this 5 is stored at index 1, the 6 is stored at index 2, and the 7 is stored at index 3. So these index helps us to get the value that is stored in a particular box. For example, if we just refer to this index 0, we can get the value 2. Similarly, for 1 we can get 5, and so on. This index helps us quickly access any element, and which helps us to get the element and use that in our code or anywhere else. Now let's understand the memory representation of array, how an array is stored in memory. As I have said earlier that an array is contiguous, and each element sits next to the previous in memory, and this is called contiguous allocation. So again, let me draw you an array. So this is an array, and we know that any variable or anything that we used in a code needs some memory space. So let's see uh, the memory that it requires. We call it address, and let's assume this is that the array starts with an address of 1000. So the first element will be at address 1000, and let's suppose this is, if each we are storing elements which are integer, and let's suppose each integer takes around 4 bytes of memory. So the second address, the second element will be at 1004, the third will be at 1008, and the last will be at 1012. Okay, and we have all told you that to refer to that particular element we can use indexing, and the first element we can refer with index 0, second with index 1, third with index 2, and this fourth one with index 3. So this indexing and this address, they all are different. These addresses are the actual data and the actual location in the memory where these elements are stored, and this indexing helps us to refer to that particular element. Okay, so this is a basic difference. The address is the actual place where that element is particularly present, index just a value that just helps to access that particular element. So address is like our home address. It tells us where the element is stored. So as we know that each element is stored continuous to each other, and each array has a base address. So this 1000 is the base address. Base address means the starting address where the array starts from. Okay, so once we know the base address and the size of each element, we can easily find out all other elements. We can easily access all other elements. For that we have a formula. I will just write it down. The formula is address of any element which is represented with index I is equals to the base address, and we add it to the index, multiply it with the size of the element. Okay, so this is the basic formula to access any element. So what is the base address? Base address is 1000. Okay, so base address is 1000. The I is the index. We know that array starts with an index 0. So 0 multiplied by the size of the element 4. So it tells that the first element is stored at the address 1000. Similarly, the second element will be stored at 1 into 4, and the base address is 1000. That is equals to 1004. So similarly, we can find, so let's say we want to find the fourth element. That is fourth element. The fourth element will have an index 3 because the index starts with 0. So let's say the base address is 1000. 3 into 4 is 12. So the last element will be at 1012. I have told you that. So this formula helps us to find the element. It helps the computer, the compiler, to find it and return the value or easily. This is what the advantage array brings with it. So once you know the base address, the size of each element that it's storing, it's very easy to find any particular element. Okay. Now you must be thinking why the indexing starts with 0. Now this is a very common used question concept, and a very commonly asked question in interviews, why array indexing starts from 0. So we have the formula that address of any element, array of I means any element, is equals to the base address plus the I, the index, multiplied by the size of the element. So basically this I is offset from base. What does this mean? Offset from base means how far that element is from the base location. So you can see the first element is always at the base location. That's why offset or the index is 0 for the first element. The second element is at a distance of 1 space that this particular element takes. So the offset from base is 1 for the second element. The third element is too far from 2 elements from the base. So this is base, another one element, and the second place is of the third element. Similarly for the fourth element, this is the fourth element. This is the base, so it is 2 elements behind. After 2 elements we get to this particular element, so the offset is 2. So this offset will clear everything, it says that how far that particular element is from the base location. And the first element is always at the base location. That's why the index or the offset is 0. Suppose we use the indexing as 1. So our formula gets changed. It's like this. Formula, if we use 1 index, it will be the address of any element with offset I equals to base plus I minus 1 multiplied by the size of element. Now, why I minus 1? Because the first element is always at index 0, it is always at the base, so we have to subtract 1 if we take index 1. So this will add unnecessary calculation. That's why we don't use 1 generally as the starting index. We use 0 because the element is always stored at the base. Now look at the declaration and initialization of array in different languages. We will be covering C++, Java, Python and JavaScript. So the first comes, C. In C++ we declare it like this, and array we give the number of elements that is going to hold, and inside it we can declare the values. So it tells that there is of 5 elements and the values of these are the values. In Java it's the same. So similarly here we said that ARR is an array. The name of the array is ARR and it holds 5 elements and these are the values. In Python, it's the name of the variable, name of the array, and it's called list in Python. The concept is of the array, and in JavaScript this is how the declaration for languages work. So we have to keep in mind one thing: in C++ and Java the arrays are fixed, but in Python and JavaScript the arrays, or which is called list in Pythons, are dynamic and they can grow and shrink. So these are the basic things that we done. Now next is, what are the basic operations that we can perform in an array and what are their time complexities. So we will just look into the basic operations that that can be performed in an array. So let me first draw you an array. So this is an array. So first that operation that we can perform is access the array. How we can access the array? So we know it all starts with index 0. This is 1, this is 2, this is 3 and this is 4. So to access an array we just have to use the index. Like ARR2. The ARR2 means the third element. So 0, 1, 2 which is the third element. So ARR2 will give the value 6. Just have to type the index with the variable name and we can get the value. So ARR2 means the third element, which value is 6. So it means it's very straightforward. The time complexity is pico of 1. It is it's constant for every element, which is ARR0, ARR5, ARR100, ARR1000. Easy. It takes the constant amount of time. The next is update. Update means we can change the value of any variable, any element in the array. For example, we want to change this 3. Let me cancel. Let me rub it 3, and we want to make it 8. So we just have to write ARR, this one is index 1 equals to 8. It means it will automatically update that value at index 1 and set it to 8. Again, it is a constant. It doesn't depend upon the number of elements. It is constant for whether you're doing ARR 0 or ARR 10,000. So it means the time complexity is pico of 1, that is it is constant. The next operation is traversal. Traversal means to get each element of the array, whether to show it or any other task. Traversal means going through each element of the array. We will do it using loop, and since it depends upon the number of elements the array holds, so its time complexity is pico of n. Pico of n means if we have 100 elements, it will take that much time. 2 elements, it will take less time. Depends upon the number of elements, so it's pico of n. Next is insertion and deletion. Let's understand insertion. Insertions mean we have to add. So let's say if we have to add some element after 8, then what we have to do, we have to make an extra space. Suppose it's already present in C++ and JavaScript, it's constant, so we already have space for 6 elements. We have just filled 4 or 5, so one space is there. So and I want to add 10 after it. So what we have to do, we have to just shift here, this one to here, this one to here, this one to here, then this is eraser. So now we have 5 here, 1 here, 6 here, and number 10 has been inserted here. So what we have to do, we have to shift each element, and again, as this operation depends upon the number of elements present in the array, so the insertion is also pico of n. So what operation we have to do, we have to shift it, and it is order of n. Next is deletion. Deletion, suppose we delete 8, then this space gets empty. So what we have to do, we have to move 10 to here, 6 to here, 1 to here, and 5 to here. Okay, so again here we have to delete and we have to shift. We just can shift, we don't have to delete. So deletion means shifting left. It is left shift, and again, as it depends on the number of elements present, the time complexity is big of n. The next is searching. Searching, if you have linear search, that means we scan through all the elements of the array. It is big O of n, but if you use binary search, then it is big O of log of n. We will cover everything in the series, searching, sorting, everything. So this is how the basic operation and time complexity is in an array. So things to remember: arrays are super fast for access and updates, but inserting and deleting in the middle is costly because all elements have to be sifted. Okay, so I think this clears up the arrays. So now you know exactly how array works, and from how they live in memory to how the task can be performed in an array. This is the foundation for almost any DSA problem that you will solve later, from searching to sorting to advanced algorithms. Okay, so if you have find the video helpful, don't forget to like the video and subscribe the channel